Hello everyone. Today I want to share about a case uh, about the particle erosion in the aluminum block in ABAQUS CAE. Uh, First, let's see the result. Uh, this is the ball particle and aluminum sample. Um, the aluminum block is the length is about 1.6 millimeter, and the radius of the particle is the radius of the particle is about 0.15 millimeter. So this is the micro model. Uh, so this is the result, and we can see the particle has initial velocity of 10 meters per second to impact the aluminum block, and the surface elements have been have been has been deleted, as we can see, and we also have the velocity of the ball. We can see the curve of the velocity. The initial velocity is about 10 meters per second, and at the end of the impact, it still has a velocity about uh, uh, let, let's see, it's about 2.65 meters per second, and the simulation time is 15 millisecond microsecond. So let's go through the model creation process. We have created two parts. One is the rigid ball, and the other is aluminum sample. Uh, the rigid ball we created as a discrete rigid, and for the machine reason, we participate the ball to 8 parts through 3 planes, and we participate the aluminum sample into 5 parts, and we need to refine the mesh in the center part. As we can see, the radius of the ball particle is about 0.15 millimeter, and as a rigid, it needs a reference point. It's located in the center of the ball. The second part, the aluminum sample, it has a length of 1.6 millimeter. It's a cubic, and we have the depth is 0.5 millimeter. Then we need to create material. It is aluminum 6065 T6. We need to define the density and elastic property and plastic property. We use the Johnson-Cook model. Then we defined the Johnson-Cook damage and damage evolution. As we can see, so this is the material property we have created. We create a section property as solid and homogeneous, and send it to the aluminum sample. Then we assemble them together and make them have the initial contact. And the ball is located in the center of the block. Then we need to create a dynamic explicit step, and the time period is 15 microsecond. And here we don't use mass scaling. To get the velocity curve of the ball, we create a reference point set. As we can see, the reference point, and then we need to define the velocity output, history output of the reference point. As we can see here, I define the velocity, displacement, and acceleration of the reference point. And in field output, I picked the failure index, C failure, and damage initiation criteria. Then I pick the status as the elements were failure. Then we go into action module. In this module, we need to create contact and contact property. So let's see the contact property. I define the friction coefficient 0.2 and created a general contact. Here we use the selected surface pairs, and the two surfaces we have created. It includes the element surface of the outside and inside, particularly in the slave surface. The slave surface is the element surface of the center part of sample block. As we can see here, it includes the inside element faces. So if the first layer of element deleted, the ball can create contact with the second layer element. This is important. If we don't have selected the element faces. If the first layer element has been deleted, the ball will penetrate the rest elements. Then we go into the load module. In this module, we paint the boundary of the aluminum block and give the particle an initial velocity 10 meters. In x and z direction. And we paint the surface of the outside. The reference point we should uh, constrain the freedom of the rest 5 freedoms. Then we create the mesh. The mesh we use bad mesh sets and we created a structure hex mesh. About the ball, I created a rigid mesh and elements. After all this, we can create a job and submit it. It will take about 15 minutes or longer. It depends on your computer. So after the completion of the computation, we can see the results. The ball particle impacts the aluminum block and the block get eroded by the ball. The elements have been deleted and we can see the Rameses stress distribution and also the damage criteria. This is the Johnson-Cook criteria. We can see when this index reached 1, the element will be deleted. And we can see the plastic string and the history output. We can get the velocity curve of the particle. As we can see, in the z direction, the velocity is from 10 meters per second decreased to 2.65 meters per second. And as the time increased, the velocity will decrease. Then we can see the energy curve. This is the kinetic energy of the model, and this is the internal energy of this model. So this is about one Bohr particle impact the aluminum block. Of this, I have tried 2 particles and more particles to erode the aluminum block, and we can see the results. In this case, I don't consider the contact between the particles. So these 2 particles have the same velocity and it hit the block at the same time and get the element deleted. And I have other models, and let's see. In this case, the 2 particles impact the block during a time difference. Here we can see the 2 particles eroded the block. We can move the force 1 and force 2. Simply say get rid of the 2 balls. We can see because there are 2 balls impact the block, it get eroded more deep, get eroded deeper. So in this case, in this model, we created the particle erosion case. Please subscribe my channel if you are interested in ABAQUS CAE. Thank you for watching.